All right, I'm here with George in the Wireless Development Lab, and tell us about what you do in here.
I'm a design verification engineer for Microsoft, and one of my duties is to do all the design testing for our wireless products. An example of this would be this wireless mouse right here. And this wireless mouse has two radios inside of it. It has a radio inside the mouse itself, and we also, if you look here in the back, have a little wireless USB dongle right here. And this has a radio in it as well. And when we test our products, we need to test both these radios, both at the circuit board level and at the fully assembled level. So as an example of this, we have some test stations set up inside this RF chamber here if you'd like to come see.
And tell us about this chamber. Is this a Faraday cage?
Yes, it is. This chamber was just installed just recently, and it's a big metal box that's earth grounded. We have this copper impregnated foam on the side, and it's used to prevent reflections within the chamber. So it gives us a nice benign RF environment to test in.
Let's check it out.
All right. So if we come inside the chamber here, we'll see I have a couple test stations set up. These test stations test our products at the board level. So if you're looking at this first station, you'll see a vector signal analyzer. And now we have this vector signal analyzer attached through this blue cable to this box. And if you look at the screen right there, what we're doing is we're measuring some of the parameters of this radio. We're measuring frequency, we're measuring power levels, we're measuring modulation. And so we would use this box to do design verification for our products to ensure we meet our specs. As another example of a board level station, we can walk over here, and what you'll see is a network analyzer. And this network analyzer is used to tune our RF radios. So if you look at the screen on this guy, what you'll see is a Smith chart. Now the Smith chart is showing frequency versus impedance for our device. And right now we have it hooked up to one of our wireless mice, and we're measuring the antenna. And as another example of a station that we might use, over here on this last bench, we have a spectrum analyzer. And now this spectrum analyzer is hooked to this wireless dongle that is inside this box. You can see it right there in the corner. And this wireless dongle is transmitting through that cable out to the spectrum analyzer, and on the screen what you're seeing is a sweep of the frequency and power of this product. And again, this station is used to verify that we did our tuning correct on the previous network analyzer. Now, once we're done at the board level, what we'd like to do is we'd like to test our products at the assembly level as well. So I can give you an example of some of the stations that we use to do that.
Let's see it.
Okay. So we walk over here, outside, and we have these big copper boxes over here. And these are, again, our Faraday cages. And when we test our products at the assembly level, we need to check for different parameters. One would be like a range test. Another would be like interference testing. So what we have right here is an interference testing setup. So if I open up the box here, if you look inside, what you'll see is a couple mice on a turntable. And we use this turntable to simulate tracking. So when it spins, the mice is looking like it's on a table and it's sending out data. We also have wiring harnesses attached to these mice. Now, we use that to simulate button presses. Off into the corners of the chamber, you'll see a couple little blue wireless devices. They're Wi-Fi devices, and we use that to create an interference while we're doing our testing. So what we'll do is we'll transmit a large data file from one of the Wi-Fi devices to another, and that's our interference source. So once I turn on everything, what happens is we are going to be measuring the data from one of our mice, and we'll be looking at it in the presence of Wi-Fi interference and interference from two of the other mice. So why don't I give you a demo of that? So if we come over here to these screens, we have two computers set up. One is attached to our Wi-Fi device, the other one's attached to the mouse under test. So if I just come over here and I take this file and I drag it to the desktop, it'll start transmitting a file from one of our Wi-Fi devices to the other. And if we come back over to the chamber here, I can flip this switch and it will start the turntable turning. So you can see the lights blinking on the Wi-Fi devices. They're transmitting a big data file. And you'll see that our mice are now tracking on that surface. So if I close up the chamber to give us a good RF environment to test in, I can come over to my screen here, and what you'll see up here is a bunch of numbers flashing in the upper corner, and that's showing data coming from the XY motion of the mouse on the turntable. Now I can come over here and open another script, and this will simulate button pressing on the mouse that we're looking at. So if I do that, you'll notice that the numbers are flashing on the right column, and that's saying we're pressing buttons. And what we're doing now is we're logging all the data from the button presses and from the XY tracking. So if I close the application now that we're done, and I open up the log file, what you will see is a whole bunch of data. And what we do with all that data is we post-process it, and we look at things like lost packets, or we look at the timing between packets. And we use that to ensure that our products meet our requirements for no data loss and for acceptable latency. So that's an example of an interference testing setup that we use. And once we're past all of our design requirements, then we move into manufacturing. So I can show you some examples of manufacturing testers if you'd like.
Let's see it.
Okay, why don't we walk over here. And off into the far corner of our wireless lab here, we have examples of some of our wireless testers. So looking over here, we have a couple stations set up. The one on the left, right here, that says Maxis, is set up to be a Bluetooth mouse tester. And the one on the right is one of our 2.4 gigahertz dongle testers. Now, on a factory floor in China, you would see many of these testers, and they are used to test our products at the board level before we assemble them into final product. So let me open one up and I'll let you see what it looks like inside. You can look inside this one here, and inside this black fixture we have a wireless mouse radio board, and we have an RF chamber in the foam just like you saw in the previous test setups. And over on the one on the right we have something similar. We have an RF box, and you can see one of our devices under test, that dongle, and it will be transmitting to another antenna inside that black fixture. And when we run these on the factory floor, we'll be checking the transmitter's power, we'll be checking the transmitter's modulation and frequency stability. We'll also be checking the receiver's bit error rate and sensitivity. So let me give you an example of how these work. So you come over to the chamber and you press the two green buttons and it'll shut the enclosure. And we can come over here to this one and do the same thing. And I come over to the software that's right here on the screen, and I just click run. And it's in the process now of running a test, and when it's completed, you'll see a pass-fail notification on the bottom of the screen, and you'll see the data on the top. And if we come over to this other screen over here for the dongle tester, we'll do the same thing. I come over here and I click start, and right here you'll see a list of the tests that are being run, and you'll see some of the graphs that are coming up showing some of our measured data. And when the test is complete, you'll have a pass-fail notification. So in this test here probably runs about 20 seconds, and this one over here probably runs about 60. And when the tests are complete, then the board moves on the assembly line to the full assembly. And so this is an example of one of the tests that are run on the factory floor. Yeah, there are other wireless tests that we run, and some of that is done by our compliance team.
So I'm here with Mike at the EMC Compliance Lab, and this is where you do more wireless testing. And what types of things do you do in here?
Well, what we do in this lab is we are measuring the unintentional radio emissions that a product will generate. Whereas in George's RF lab, he's measuring parameters of the actual RF signal we're broadcasting. But any type of electrical device will generate unintentional radio waves all across the spectrum. And in our group, we're the compliance group, we need to limit that amount of noise because agencies like the Federal Communications Commission require us to stay below these limits. So we test our products here during development to make sure we're going to comply, and we can, when our product is developed, we can sell it to the markets we want to sell to. So that's our main purpose.
Cool.
So this room behind me is a RF anechoic chamber, and this is our test environment that we use. It's a heavily shielded, quiet RF room. So when we make measurements in here, we're measuring only the device that we're interested in. So I'll take you into the chamber here. So what we basically have is we have a shielded room. It keeps all the ambient noise outside. So we have a very low noise floor. And we want to measure a mouse. We know we'll just be measuring the mouse or whatever is on the table. You see all these materials on the wall. These are absorbing materials. So they absorb RF energy and keep it from bouncing all around. And ideally, we could do this in an open area test site with no walls, away from any noise sources, and that would give great results. But where we are, we have the shielding to create a quiet level, and then the absorbing materials sort of negate the shield, so they sort of cancel each other out to some extent. So this is a test setup that comes right from the FCC standards that we test to. So there's a particular table height, 0.8 meters. There's a receiving antenna over here on a mast that will raise up and down. And we have a turntable, so what we're actually doing is we're measuring the radio waves from the mouse, and we are trying to maximize that emission. So you must, per the standards, you try to create a worst case condition.
Yeah.
So we're rotating the table, we're raising and lowering the mast, we're changing the polarity of the antenna, all in an effort to have those emissions as high as possible. And if under those circumstances we're passing, we've passed. Mm-hmm. If not, then it's our job to try to find the source and try to have some mitigation to bring those emissions down. So let me show you, we can go outside and I'll show you how the test is actually run, a quick scan. So we have the device out here on the table, and the measuring equipment that we use is this spectrum analyzer, which is connected to the antenna inside, and we do a sweep.
Spectrum analyzers run in Windows? That's pretty cool in itself.
This is our latest and greatest, and all the Agile analyzers, or the high-end ones now, run Windows.
Nice.
So what we'll do is, first off, we'll take a look at a large section of the spectrum. Here we're looking for individual peaks that we'll later investigate more closely. So under this test, we would maybe do a quick raising and lowering of the antenna. Rotate the table. And when we do see an emission that we are interested in looking at more closely, we'll zoom in. Let me find one for you. So here's an emission right here. And if you keep focused on that, there's a certain level we have now, but as I rotate the table, you'll see the emission on the screen rise and fall. Now it's going into the noise floor. And we'll bring it back. When we feel we've had it maximized, we'll take our final reading, compare that to the agency limit, and then decide if we have a product that's passing or a product that's failing, and we go from there to investigate the source. So that's a general overview for you. Thanks for watching.
Cool. Okay.